axis. So what we have done in the last class, we have just see that we have angular momentum vector, and this vector is nothing Lx I cap, Ly j cap, and Lz k cap. And obviously, this is just a angular momentum operator, and we have a very nice commutator. Lx Ly is equal to I h cut Lz, and similarly we have cyclic nature of Lx Ly and Lz, and we find a new operator, and that new operator is L square, and Lz is going to commute, and we already find our Lz operator as minus I h cut del upon del phi if you are transforming all the thing into a spherical polar coordinate, and we have find Lz is going to operate on phi will be function of phi is equal to mh cut phi, and where this phi is nothing 1 upon root under 2 pi exponential I m phi. The value of m is very interesting, that is 0 plus minus 1 plus minus 2 and so on. So this thing we have learned. So now next duty is that we have to calculate what are the eigenvalue and eigen state of L square. ठीक है? कुछ पूछना है यहां तक? चलिए. So let's try to go for the calculating the eigenvalue and eigenvector of L square. So L square, let's say L square will operate on, first let's say what is your L square operator. So L square operator is nothing but minus h cut square, and you can just see this particular operator, and you can identify from your mathematics that which type of operator is there or which type of mathematics is there. So del upon del theta, del sine theta, del upon del theta, sine theta, del upon del theta, plus 1 upon sine square theta, del square upon del phi square. So this is our L square operator. Now, do you identify this particular thing? इसको छोड़ो, इसको आइडेंटिफाई कर पा रहे हो? मैथमेटिक्स में कहां यूज किया है इसे? बताओ, सोए मत रहो, अब आपकी कोर्स, आप काफी मैच्योर हो चुके हो क्वांटम मैकेनिक्स में. हाँ, हाँ, क्या था ये बताओ? What is this particular thing?
Laplacian.
Laplacian, the angular part of Laplacian, isn't it? When you are using into spherical polar coordinate. जाकर के रिवाइज कीजिएगा, okay? So this is your Laplacian. Now you can see we have L square is function of theta and phi. So I can write L square, let's say psi, theta and phi will operate, will give us lambda, and that is psi, theta and phi, where psi, theta, phi is the eigenstate of L square with eigenvalue lambda. Obviously lambda should be some real number, and it should be some positive number because we are talking about L square, isn't it? So ये natural instinct तो हमारे पास है. But now how we are going to solve it? So we have L square and Lz is going to commute to each other, and if they are going to commute each other, that means L square and Lz can be simultaneous eigenstate. So if they are going to commute each other, they can have simultaneous eigenstate. So psi theta phi is also eigenstate of Lz. If it is eigenstate of L square, so psi theta phi is also eigenstate of Lz. Now, if psi theta phi is also eigenstate of Lz, and we know the eigenstate of Lz is 1 upon root 2 pi exponential Im phi, then can I write psi theta phi? Hence, theta and phi are the random variable but independent random variable. Then can I write psi theta phi is equal to some function of theta into e to the power Im phi? Are you agreed with this logic?
Yes, sir.
Yes, because we are using the fact that this Lz have eigenstate e to the power Im phi. And if we can do the variable and separable, then theta part should be separate and phi part should be separate. So if we are separating the phi part, this psi theta phi have to be also eigenstate of Lz. Then obviously this psi theta phi must be proportional to e to the power Im phi, and this will make our life very easy. So let's see what we are going to do. We will just put this thing into this equation. So just help me whether I am correct or wrong. So this is h square, h cut square. And for this particular function, e to the power Im phi is a constant because it is partial in theta. So I can write e to the power Im phi, and whole thing can be transformed into a total derivative d upon d theta sine theta d upon d theta f theta plus, now this is only function of phi, so this is partial with phi. So for here we have to differentiate this thing twice to the power 2 with phi. So we have 1 upon sine square theta, and if you are going to differentiate twice, so Im into Im will come there. So this is minus m square e to the power Im phi f theta is equal to, so this is our thing, and this will be lambda f theta into e to the power Im phi. देखो यहां तक सही लिखा हूं? Correct है ये? And this will be going to bracket, don't worry. Now what we will do, we will just try to equate the coefficient of e to the power Im phi on both sides. So when we are going to equate the coefficient of e to the power Im phi on both sides, let's see what is going to happen. Now, then we have minus h cut square, and we have 1 upon sine theta d upon d theta sine theta df upon d theta minus m square upon sine square theta must into f theta must be equal to lambda into f theta. This derivation is not very important for your examination, but it is important to understanding the way that how we can use mathematics to find the desired value of physics. You will see. It's a very interesting, and it is one of my favorite derivation. Okay. What I will do, I will take minus h cut square here, and I will keep it into this side. Then what I will get? I will get 1 upon sine theta d upon d theta sine theta df upon d theta plus lambda upon h cut square minus m square sine square theta f theta must be equal to 0. So we have to solve this equation. This is a very nice one. So how we will solve it? So what we will do? We will make it little bit. We will just change little the variable, and what we will do? We will just try to put cos theta is equal to x. Why we are putting this? Because we can have minus sine theta d theta is equal to dx, and from here we can easily write 1 upon sine theta d upon d theta is equal to minus d upon dx. लिख सकते हैं ना? Just by using the fundamentals of calculus.
Yes.
Okay. Now, so here we have, look at this particular thing. This all thing we can easily write minus d upon dx. लिख सकते हैं ना? And if we are dividing with sine theta here, then we have to multiply with sine theta here. Then this sine square theta can be written as 1 minus cos square theta. लिख सकते हैं ना?
Yes, sir.
Yes. So we can write, we can just reorganize this thing. That is 1 upon sine theta d upon d theta 1 minus cos square theta d upon d theta, and sine theta is also there. F theta is also there. Plus lambda upon h cut square minus m square sine square theta f theta must be equal to 0. And now we can put all this thing here. So minus minus will be plus. So there is not any problem. So we have d upon dx 1 minus x square d upon dx, and now we can have fx. Or x is nothing but cos theta, don't worry. Plus lambda upon h cut square minus m square 1 minus x square fx must be equal to 0. Clear है ये? And now when we can go for this particular differential equation, then we have so you can have this equation. So this equation is d square fx upon dx square 1 minus x square minus 2x. We have to differentiate this one, and you have df upon dx plus lambda upon h cut square minus m square 1 minus x square fx must be equal to 0. Okay. Now, this is your mathematics. Let's come to physics. What we want? हम चाह क्या रहे हैं? ये जरा बताइए.
Eigenvalue of L square factor.
Yes.
Eigenvalue और eigenstate है ना? Basically, f निकालना चाह रहे हैं. And this f should be a part of Hilbert space.
Yes, sir.
Yes. So this f should be part of Hilbert space, or at least you can say this f have to follow some orthogonal or some orthonormal relation?
हाँ सर।
होना चाहिए। आप तो क्वांटम मैकेनिक्स के लिए सॉल्व कर रहे हो ना इस डिफरेंशियल इक्वेशन को। आप अपने सॉल्यूशन को किस डायरेक्शन में लेकर जाना चाहते हो? आप अपने सॉल्यूशन को उस डायरेक्शन में लेकर जाना चाहते हो जिस डायरेक्शन में आपको f की कुछ वैसी वैल्यू मिले, f के कुछ वैसे फंक्शंस मिले, दैट शुड बी have some orthonormality, some orthonormal relation, some kind of orthogonal relation. ऐसा ही तो f का नेचर होना चाहिए. So whenever this type of challenges came, you have to move towards polynomials. क्योंकि polynomial की inherent property orthogonal property होती है ना? और सारे property होते हैं. And if you will see all these differential equation in a very nice way, and if you will just neglect this part little bit, and somehow if this number lambda by h cut square is equal to some L into L plus 1, that means this will be the multiplication of two positive conjugative number, then this all equation is identified as which differential equation?
Bernoulli's.
Bernoulli's, no. Legendre differential equation. Okay? So I think आपका भी special function हुआ नहीं है. So जब आपका special function होगा, then you can easily able to give the answer that lambda upon h cut square is equal to L into L plus 1, and this all thing is identified as what? Legendre differential equation. And here this part is coming. Okay? So if this part is there, and you can see at x is equal to 1 and minus 1, x is equal to, if this is there, then you have fx is something like Legendre polynomial. And now you can see at x is equal to plus minus 1, x is equal to plus minus 1, this all equation is going to what? Diverge. है ना? Plus minus 1 is something like singular point. So avoid this singularity. So if you want to avoid this singularity, then you have the value of m must be bounded between minus L to plus L. Then you can avoid this singularity, and your solution, this fx, is something known as LMX. This is identified as associate Legendre polynomial. Okay, so now we have this kind of situation.
सर
हाँ बताइए.
लैम्डा बाय एच कट स्क्वायर इक्वल टू एल एल प्लस 1 तक लीजेंडरी इक्वेशन तो समझ में आया. बट सर व्हाट इज मीन बाय x इक्वल टू प्लस माइनस 1 सिंगुलरिटी?
अरे भाई x इक्वल टू 1 पुट करो, क्या आएगा? पूरा देखो क्या होगा, एक बार पुट तो करो. अरे पुट तो कर भाई, x इक्वल टू 1. जीरो नीचे जीरो होगा तो पूरा क्या होगा? इन्फिनिटी नहीं होगा?
इनफाइनाइट.
तो ये अच्छी बात है.
नहीं सर, इन्फिनिटी अच्छी बात नहीं है.
अरे भाई पूरा इक्वेशन तो तुम्हारा डाइवर्ज करके क्या करोगे उसका?
नहीं.
तो इसी को तो सिंगुलर पॉइंट कहते हैं.
यस सर, समझ गया सर.
कॉम्प्लेक्स नंबर तो पढ़े हो ना, कॉम्प्लेक्स वेरिएबल?
यस यस सर, यस सर, आप समझ गए सर.
समझ गया है? तो इस, और आपको पूरा एजेंडा क्या है कि आप उस सिंगुलरिटी को अवॉइड करो. आर यू गेटिंग माय पॉइंट? तो सिंगुलरिटी को हम कैसे अवॉइड कर रहे हैं? अगर ये कंडीशन हो रहा है, then this singularity can be avoided, and you have this as your Legendre, associate Legendre polynomial. So now we have eigenvalue and eigenvector. And for the orbital angular momentum, here L can be, now m की वैल्यू कहाँ है, -L to +L, और m की वैल्यू आपकी क्या हो रही है, 0 +-1 +-2, ऐसा ही है ना. So L will be your 0, 1, 2 and 3 on for angular orbital angular momentum. और आप जब टोटल एंगुलर मोमेंटम में जाओगे तो L आपका फ्रैक्शन भी हो सकता है. So there is not any problem. ठीक है, but they will be move in a step of +1. अगर ये फ्रैक्शन होगा तो क्या होगा, हाफ आएगा तो क्या होगा, 3/2 एंड समथिंग एल्स. दैट इज डिफरेंट स्टोरी. बट अभी हमारा m चूंकि इंटीजर है and that is positive and negative integer, so L can be 0, 1, 2, 3 and so on. And our psi theta phi is basically f theta e to the power im phi, and you can write L and m, और इस पूरे चीज को लिखते हो आप YLM थीटा पाई, इन दोनों को कंबाइंड करके, एंड इसे आप क्या कहते हो, स्फेरिकल हार्मोनिक्स. इसे क्या कहते हैं, स्फेरिकल हार्मोनिक्स. एंड what is the normalization condition of what is the orthogonal condition of a spherical harmonics? You have orthogonal condition y star L dash m dash theta phi y L m theta phi. इंटीग्रेट करेंगे ओवर द ऑल पॉसिबल वैल्यू ऑफ थीटा एंड ऑल पॉसिबल वैल्यू ऑफ फाई. तो यू हैव टू इंटीग्रेट इन अ सॉलिड एंगल, है ना. सो द ऑर्थोगोनल रिलेशनशिप इज गिवन बाय something like, look at here. So I am removing this part. So you have to integrate for all possible theta and all possible pi. So 0 to pi, 0 to 2 pi, and this is identified as delta L L dash, delta M M dash. And this spherical harmonics theta phi can be represented as a Dirac notation, that is L and M. Yes, are people comfortable? So let me conclude the final thing. यहां तक कुछ पूछना है तो पूछ सकते हो आप. Are people happy? बोलिए बोलिए.
जो ऐसा मतलब जो फंक्शन आ रहा है वो स्पेरिकली सिमेट्रिक है, इसके लिए नाम ऐसा कुछ है क्या, स्पेरिकल हार्मोनिक?
स्फेरिकली सिमेट्रिक कहां से, मतलब ये क्यों होना चाहिए स्फेरिकल सिमेट्रिक? व्हाट डू मीन बाय, आप हमेशा इस तरह का वर्ड जो यूज करते हो उसके पीछे कुछ लॉजिक तो होना चाहिए.
साइड प्लीज.
मतलब सर नाम स्पेरिकल हार्मोनिक,
स्फेरिकल हार्मोनिक्स इसलिए है क्योंकि वो स्फेरिकल पोलर कोऑर्डिनेट्स में है. हार्मोनिक्स इसलिए है क्योंकि देयर इज ऑर्थोगोनल रिलेशनशिप.
ओके
ठीक है. नाउ so what we have seen, we have now very interesting result that L square will operate on y lm theta phi. That will give you L into L plus 1 h cut square y lm theta phi. This is equivalent to writing L square will operate on L and M, that is L into L plus 1 h cut square y lm, sorry, that value is equal to L m LZ will operate on y lm theta phi. That value is equal to mh cut y lm theta phi. This is equivalent to LZ lm mh cut lm. Okay, so this is basic thing that you have to learn here. Okay, and now I will just give you some basic one or two basic function of a spherical harmonics which will be useful for your calculation. Okay, so let's first go for y 0 0. L is equal to 0, m is equal to 0. So this will be 1 upon root 4 pi. Okay, so this is your y 0 0. What is this? L is equal to 0, m is equal to 0. Now y 1 1, that value is equal to minus root under 3 upon 8 pi sine theta e to the power I phi, means L is equal to 1, m is equal to 1. Y 1 0, that is we have 3 upon 4 pi cos theta. Obviously m is equal to 0 means e to the power I phi is 0. So L is equal to 1, m is equal to 0, and y 1 minus 1 is something 3 upon 8 pi sine theta e to the power minus I phi. L is equal to 1, m is equal to minus 1. Yes. So you have this kind of situation. Now your next question should be, what will happen to Lx and Ly? क्या हम उसे पूरा ही छोड़ दें? क्या करें उसके लिए? I just want to learn what will the nature of Lx. I just want to see the all symmetry of Lx and Ly. It is different matter that it is very easy to solve. But I am interested to find what is the Lx and Ly. So the answer is, let's come to a next analysis that is known as what? Ladder operator. Okay, so let's come to ladder operator. यहाँ तक clear है ये? Okay. Let's come to ladder operator. Same ladder, जिसको आप सीढ़ी भी कहते हो, है ना? Okay, ladder operator. Now we have two information right now. L square will operate on Lm. That value is L into L plus 1 h cut square Lm, and Lz will operate on Lm, will give you m h cut Lm, where L is 0, 1, 2, 3 and so on, and m will be from minus L to plus L. We will prove it again, this particular thing. So now we can define a new operator. This new operator is L plus operator. This is Lx plus I Ly. Okay. Similarly, the complex conjugate of this one is L minus, that is Lx minus I Ly. Okay. And obviously L square and L plus is going to commute. L square and L minus is also going to commute. Okay. So L plus and L minus is also going to commute. Now, let's try to see what is going to happen Lz and L plus. What is going to happen Lz L plus? So we have Lz Lx plus I Ly, and we have this thing as Lz Lx commutator plus I Lz Ly. So Lz Lx will be what? क्या होगा? Are you there या आप लोग चले गए हो?
Ly.
What will be this? Lz Lx?
Iota h cut L.
Iota h cut
Ly.
Ly. Very good. What about Lz Ly? Minus I h cut Lx.
H cut
Lx. So what I can write? I into I is what? Minus, 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 plus. So we can write I h cut. Sorry. So we can have h cut common, and we have Lx plus I Ly. And this is nothing, h cut L plus. Sorry, people happy with this calculation?
Yes, sir.
Yeah, okay. Now, let's try to go for a same type of calculation which we have done into harmonic oscillator. So you remember Lz L plus is going to operate on Lm is equivalent to L plus Lm. Yes or no? And now I can write Lz L plus minus L plus Lz is going to operate on Lm. We have L plus Lm, and here we have Lz L plus Lm. याद आ रहा है कुछ?
सर h cut भी तो है ना?
H cut भी है. Yes, H cut भी है. Thank you. H cut भी है. Very good. याद आ रहा है ऐसा कैलकुलेशन किया था?
Yes, sir.
Lz will operate on Lm. What you will get?
M H cut
M H cut
Lm.
L plus Lm is equal to H cut L plus Lm. Are you happy? Now this will go into this side. ये दूसरी तरफ जाएगा. Then what will happen? Lz L plus Lm is equal to M plus 1 H cut L plus Lm. Are you people happy? So I can say that L plus Lm is also eigenstate of Lz with eigenvalue. क्या eigenvalue है?
M plus 1 H.
M plus 1 H cut. Very good. So now कुछ याद आ रहा होगा, है ना? हार्मोनिक ऑसिलेटर याद आ रहा है कुछ?
Yes, sir.
Yes. Good. So what is going to happen? So Lz will operate on Lm. What you will get? MH cut Lm. Now Lz will operate on Lm plus 1. What you will get?
M plus 1 H cut.
Very good. M plus 1 H cut. और यहाँ क्या होगा?
Lm.
Lm.
M plus 1.
M plus 1. Okay. Now LZ is operating on L plus LM, what it will get? M plus
M
1
plus 1
H cut
LM plus 1
L plus LM, ठीक है ना?
सर.
तो यहां अगर मैं कंपेयर करता हूं this to this to this, then obviously this is proportional to this one, isn't it? कह सकते हैं या नहीं?
Yes, sir.
So we have L plus LM is proportional to, I am not claiming that it is normalized, I am just saying it is parallel to that one, then only it is getting this thing. So this will be L M plus 1, and please, I am not changing L. Why? Because L is independent and this is only associated to L square. So there is not any sense that we are changing this thing. So we have L plus LM is nothing but C plus L M plus 1. Let's write the bra part of this. इसका bra लिखोगे तो क्या होगा?
Bra L minus LM L minus
LM, very good. L minus
L minus
C plus star
star
bra L और M plus
plus
1.
1.
And this is orthonormal. अभी हमने आपको orthonormal relationship दे रखा है ना? So let's try to multiply these two things. अगर दोनों को आप multiply करोगे, then let's see what is going to happen. So we have this kind of situation. L M L minus L plus L M is equal to mod C plus square L M L M, and this value is equal to what? 1. Now let's calculate L minus L plus. So L minus is Lx minus I Ly. L plus is Lx plus I Ly. You have Lx square plus I into I minus 1 minus into minus is plus 1 Ly square plus I you can take common Lx Ly minus Ly Lx. है ना? What is this thing? ये क्या है? Commutation between Lx and Ly. है ना? This thing is nothing but commutation between Lx and Ly. So Lx square plus Ly square, I can write L square minus Lz square plus I into commutation of this thing is I into I cut Lz. So my L minus L plus operator is L square minus Lz square minus H cut Lz. ठीक है ना?
सर ऊपर m plus 1 नहीं आएगा? LM plus 1.
कहाँ m plus 1 आएगा? हाँ, okay, good. Thank you. M plus 1. Good, thank you. Yes, जरूर आएगा. सही लिखा हूं मैं?
Yes, sir, correct.
अब देखो मैंने ऐसा क्यों किया? बिकॉज हमें सारा इंफॉर्मेशन तो L और L स्क्वायर का ही पता है ना?
Yes, sir.
तो हमें सारे चीज को तो उसी के टर्म में लिखना पड़ेगा, तभी तो हम कैलकुलेशन तक पहुंच पाएंगे. यस या नो?
Yes, sir.
Okay, so just put it here and we will get the final thing and it will very interesting. So so this value is C plus mod square is equal to L M, and here is L square minus Lz square minus H cut Lz L M. So C plus mod square is equal to L square is operating on this, L into L plus 1. Lz is operating on this, M square. Lz is operating on this, M. And obviously, H cut square is there. And you have mod C plus square is L plus 1 minus M plus 1 H cut square. And hence this number have to be positive. Then M should be always less than equal to M. नहीं?
सर वो C mod C square M plus 1 नहीं आएगा
क्या? अरे ये तो 1 हो गया नहीं?
नहीं सर, उसके जो साइड में आपने लिखा है ना,
क्या?
mod C to L square minus LZ square minus H cut LZ.
फिर क्या गड़बड़ है यहां पर? अरे बोलो भाई, क्या आपको क्या गड़बड़ क्या लग रही है?
उसी लाइन में मुझे लगा कि M plus 1 आएगा, बट नहीं आएगा।
नहीं आएगा, ठीक है। तो M की वैल्यू क्या होगी? ऑलवेज लेस देन माइनस, सॉरी, M की वैल्यू हमेशा L से कम होगी। याद है क्यों होगी? सिंगुलरिटी खत्म करने के लिए वहां पर, रिमेंबर?
यस,
स्टार्ट ऑफ डेरिवेशन
शुरुआत में बताया था ना, और यहां पर मैथमेटिक्स से भी प्रूफ कर दे रहा हूं, डोंट वरी। ओके, सो आई विल स्टॉप हियर and we will take the property of L minus. By the way, what we get? We get L plus LM operator is very interesting one, that is L plus 1 minus M plus 1, and this is M plus 1. H cut is also there, and you have L plus L and L is equal to 0. So you cannot go beyond the M, beyond the L. If M is equal to L, you cannot go there. We will discuss which type of interesting thing we are discussing. Okay. By the way, you can see we can identify L plus. Similarly, we will identify L minus. And once we will identify L plus L minus, we can easily say what is my Lx, what is my Ly, as like we have done into harmonic oscillator. कुछ कोरिलेट कर पा रहे हो?
Something like raising rolling operator.
Exactly. Something like raising and lowering operator. But वहां पर क्या था? एक हमारा क्वांटम नंबर लोएस्ट बाउंडेड था,
एक घट रहा था, एक बढ़ रहा था।
यहाँ भी एक घटेगा एक बढ़ेगा, लेकिन M की मिनिमम वैल्यू ही फिक्स थी, है ना?
हाँ सर, यहाँ
पर मिनिमम और मैक्सिमम दोनों फिक्स रहेगा। We will discuss this thing. Anyway, so I think we should stop here. Take your dinner, revise it, okay? And we will discuss in the next class. ठीक है? Thank you.
Thank you, sir.
Thank you.
थैंक यू सर।